Okay, hello?
Yes, we hear you. Our next talk is Frank Ritter. And Frank, we see your presentation now, so go ahead.
Okay, well, thank you very much. I first wanted to thank John and the SOAR group for organizing this event. It's great to be here. It seems a bit like Dartmouth, but distanced in time and space. And I think this will be a real resource for the cognitive architecture, cognitive modeling community. John asked me to talk about something that I was excited about, and further work on applying simulated eyes and hands to me is exciting. And so what we're going to talk about, David Schwartz and Farnaz and I today, is about extending ACTAR with JSegMan to perform a long-term task, which is driving a bus. And it has implications for perception, motor output, their coordination, which we don't go into much, fatigue, motivation, and the effect of behavioral moderators on the whole ensemble. So what we have here then is a brief overview of ACTAR, and as I'm trying to use multiple tools, what we have is the ACTAR cognitive architecture, which many of you are aware of. Some of you might not be. Citations at the end of the talk provide pointers to John Anderson's work. And of course, I should add the ACTAR website as a useful resource. There is a cognition level that is, let's see if I get that to pop up. That's in here. There's production memories, and which are then if-then rules. You can see them as procedural knowledge. There is chunks, which are declarative memory elements, as opposed to the chunks which are SOAR productions in SOAR. These pieces of information will hold information like where on a screen to look or what the next step in a task is. There is a perceptual motor layer, which can be, which what we're really going to see some action on today. There's a vision manager, which will take motor commands and pass them out to the environment, and then look at the screen. In ACTAR, this is done through a Lisp-based window or through very special APIs, although there's a somewhat general API created at RPI in that area. Oh, excellent. I have now lost my mouse. Okay, going on to the next slide. In an effort to work in that area, we have worked with Robert St. Amant for a while ago to create a system called SegMan, which takes sensors and effectors. It generates those for cognitive agents. Rob came at it from an agent AI approach. I was more interested in a cognitive modeling approach. It captures the screen as an input and then segments it into groups. And you can see that in the case on the right-hand side of the figure, there's a group 1, which is the F, and then you might find group 2 being the dot on the eye and group 3 being the body of the eye. The same thing can be done hierarchically to buttons and menus. We can simulate user input, and those are key presses and mouse movements and mouse clicks. He and I, over the course of maybe a decade, used it with solitaire, drawing programs, driving a little robot around, driving a game in Java. One of the best and most fun interfaces was a offshore casino where one of my graduate students tested a theory about how to win at roulette using their practice money. That interface was designed to be adversarial, and it was not designed for agents to use, but we could use it with SegMan. Dialing telephones was one of the first and classic cases, and We had another student did a master's project driving a robot around. It worked under Windows only though, and it became hard to maintain. So the natural effect of that is to move it to another, to update it. And Farnaz is now going to tell you about her work.
Thank you, Dr. Ritter. In line with SegMan, we have developed JSegMan, Java segmentation and manipulation. JSegMan parses the screen and uses the operating system to execute commands. In JSegMan, we developed a new type of knowledge, visual patterns. Visual patterns are small images that represent visual objects. For instance, on the right side of the screen, you can see head button and tail button. And those two images under those are the visual patterns for these visual objects. We have used JSegMan in 3 studies. And the first study, we used the decimal task that contains 14 spreadsheet subtasks, such as opening a file, clicking on a screen, and typing a formula. This study task environment is Emacs spreadsheet mode, and Emacs is an open source editor that we use here. Our model with JSegMan was able to complete the 14 subtasks and interact with the same environment as users in this study interacted with. In the second study, we used a bias coin task, which is based on the probability choice experiment. Our model chooses head or tail, clicks on the head or tail button, and then adjusts the head and tail probability by seeing visual feedback of the environment. When it clicks on head, for instance, it can see match or mismatch, and then based on that, our model with JSegMan can learn how the coin is biased and interact with this environment, which is a website. In the third study, we use the same 14 subtasks of the decimal task, but we modify them so we can use them in Excel environment. Again, our model with JSegMan, we're able to complete all the 14 subtasks and interact with Excel environment. As you can see, JSegMan is not limited to only one platform, and it can interact with different environments. Next slide, please. This figure demonstrates the main structure of JSegMan. In JSegMan, we use Emacs as our inner process communicator. We have 2 main processes. One is Actar and the other one is Java or JSegMan. These 2 processes can communicate to each other, and then JSegMan provides cognitive models with simulated eyes and hands. And the list of functions on the left side of the screen has been implemented in JSegMan and can be executed in the task environment. JSegMan uses computer vision methods to parse the screen and find the visual patterns on the screen. The last 2 functions are new functions that we added to JSegMan for the new task of Desert Bus that David will explain in details in future slides. If you are interested to have more information about JSegMan, please check the project website. Also, more information about the task and task environments that we have used for JSegMan, you can check these references. David will now continue.
Okay, thank you, Farnaz. Next slide, please. Cool. So the task we are using is Desert Bus. It was a game designed by Penn and Teller to show that not all games were offensive and violent, and so this was made to be the least offensive game possible, and it was supposed to come out in a collection called Smoke and Mirrors in 1995 for the Sega CD. A picture of the original game is in the bottom left. The game was finished, however, it was never actually released. Years later, a copy of the game was sent out to somebody and was used for a charity event called Desert Bus for Hope. and that prompted a recreation of it by Dinosaur Games, and you can see a picture of that in the bottom right. So the player in this game takes the role of a bus driver who has to drive from Tucson, Arizona to Las Vegas, Nevada. That journey is depicted in the top right there. The game takes this route and approximates it as a straight line, so you're just driving on a straight road through the desert. The bus can go a maximum of 45 miles an hour. The player controls it by using the WASD keys, so they can hold W to accelerate the bus. Pressing or holding the A key will steer to the left, D will steer to the right, and S will apply the brakes. Interesting thing about this game is that it runs in real time. So it will take about 8 hours in order to drive from Tucson to Las Vegas. And all this time, the bus will slowly be pulling to the right. And if the player goes off at any point, they will be towed back to Tucson in real time. Upon completing one leg of the journey, they receive 1 point and they're asked to turn around and do it again for another point. There's no pausing in this game, so all of this has to be done in one sitting. Next slide, please. So to play this game, we developed a simple model. It has 5 declarative memories, most of which being about what the controls do. So right, W to move forward, A left, D right, S to stop, and its goal where it's driving. And 7 rules about finding visual targets and making decisions. The flowchart on the right depicts the decision cycle of the model. So what it starts by doing is finding the yellow dividing line, checking if that line is past about 900 pixels on the screen, and if it is, it's going to move to the left to readjust the bus into the center of the road, or it's going to move forward. What's interesting to note here is that moving forward is constantly in this decision cycle. And that's because ACTR models cannot hold down keys. And so in order for our model to actually drive the bus, it's going to have to constantly be pressing the W key and moving in small increments. In addition, moving forward and moving left are considered as separate states because ACTR doesn't have the ability to perform parallel motor actions. So the motor module has several states to represent actions that are in the queue for typing or for moving the mouse. But there's only one state that handles execution. So as soon as one action is being performed, no other actions can occur. And all motor actions in ACTR relating to the keyboard involve pressing and releasing a key. So at no point will there ever be 2 keys that can be held down at the same time. So while I and other people who I've seen play the game will hold down the W key and tap the A and D keys to realign their bus in the road, that's something our model does not have the ability to do. It has to release the W key and then press A to steer to the left and get back in the center. Together, these issues are going to stop the bus from staying at its top speed, which is going to make the journey even longer. In addition, when we were developing this model, we played around with where the player and the camera in the game was looking. The original game just involved you driving a bus, with a controller. On the new version that was made by Dinosaur Games, it is a full 3D environment that, supports VR and not VR controls. If you don't play with the virtual reality controls on, you can look around inside the bus using the mouse. So we thought it would be interesting if we could have the basically the player look at the center of the road for where they believe the line was, what we found with JSegMan, and have it basically as a real bus driver that's looking out at the road and will adjust its view or adjust their view. In ACTR, when you go to move the mouse, you need a visual target to move to. So we'll find the dividing line, hand that to the motor module and say, move to this visual location. And sorry, I was looking at the chat. What we noticed is that when we go to do this in ACTR in a first-person game, it's typical for the viewing angle to actually overshoot the target we're looking at because there's a sensitivity factor that's hidden in the code of the game that controls how far you have to move the mouse in order to have a change in the viewing angle in a first-person game in a 3D environment. Next slide. So we have a little demo video to show some of the issues with having to tap keys instead of being able to hold things down. And David Curious had in his presentation before a quote about show me a model that does not fit. So I present to you a model that does not fit. You can start the video now.
Video started.
So did anyone catch that? And
Wait,
once
there-
again,
there-
we're all over Zoom and we're all muted. So I guess I will not know, but we do have a zoomed in version to make things a little clearer. So next slide, please. And to make this a little more obvious, we have a little line that's going to show up. Go, and you can start the video now. So we get very incremental movements here from the model tapping keys. So we're technically driving, but the issue is this model really does not have any hope of making that full drive between Tucson and Las Vegas. So while right now it doesn't accurately model players or perform the task well, in the future it can, and it can be used to study some very interesting things. Next slide, please. So we're using JSegMan right now to detect visual targets in our application and actually interact with it. And once we are satisfied with how we have the perception working and interaction in the game, we can start investigating these limitations of motor output to support holding down multiple keys or support holding down keys and using multiple keys at the same time. We can also start working with issues in first-person games and having a model that manages that relationship between the sensitivity parameter in the game and where a visual target is, and identifying if it has correctly adjusted itself to look at it. Once we fix these issues with the motor movement, we'll have a model that can drive endlessly. But people, when they're playing this game, don't play it endlessly. And so we can use this as a way to start studying fatigue, right? As a player, as a person plays this game, they're going to become tired, and that's going to affect how they play until the point where they eventually will either go off the road and lose the game, or they will choose to stop. Similarly, we can start studying the motivation about why does a person want to play this game versus handling their other responsibilities, and how do they manage that, and what goes through their head when they decide to stop. So with that, I will turn it back to Frank to add some concluding remarks.
Okay, thank you. I think I can see that I'm speaking. So what we're headed towards is we're designed and are implementing a long-running cognitive model. Not that there haven't been models that have run for a couple hours in synthetic environments, but this offers to run for 140 hours. And it thus opens up new worlds for models that can see and act, including, the video games, where you don't have to have an API, but you can interact using what you see and what you type, or how you move the mouse move. It opens up new problems and issues where the model can run for a long time, and there's a problem where ACTAR currently stays very fresh and is happy to perseverate or do the same task for a long period of time, whereas users wouldn't. And if we continue on that line, we can make ACTAR or other architectures want to take a break at 40 minutes and have other physiological effects on cognition, which will make them harder to work with. And so we'll have to reset our model and give it a dose of caffeine or give it a release from inhibition from previous memories. And it will make the general work a little bit harder. So then to wrap this up, then I'm going to try to move to the next slide. There's the papers that we've referenced in here are nearly all of them are available online. We need to acknowledge the support from ONR and a SMART fellowship to David. And I would just follow up or conclude with my lab has built a tutor that teaches skills to obstruct pandemics. It's at stopthespread.health. And we stand by ready for your questions. I think they're coming in via questions, but via the chat.
Yes, thank you. We have a few questions in the chat. The first one was, could JSegMan be attached to a different cognitive architecture, such as SOAR?
Oh, I can answer that. So JSegMan has a separate process. So in theory, it can communicate with any other processes like Actar or SOAR. Also, the way JSegMan works is like pausing Actar process and execute the task, provide the feedback for the Actar process, and then Actar continues the task or the process itself. So in theory, as I said, it can use with SOAR.
Okay, thank you. There are a couple suggestions about doing parallel motions that I will let you guys read for yourselves. So the next question was, do you already have ideas for how to do, how to model fatigue in your model?
So going forward with that, what I would do would be to start using ActRFE, which is an architecture / modification that Dr. Chris Dancy over at Bucknell has. That incorporates the HUMOD physiological simulation system in with ActR and allows kind of models the connections between cognition and physiology and vice versa. And so the HUMOD side of that simulation can simulate, somebody doing something over an entire day or longer, and will mess with parameters within ActR to start adjusting performance. And that's where I would start to make it model fatigue. But I only have that as a starting point. I don't have any finer details for you, unfortunately.
That's fine, thank you. The next question is, what do you suppose the relation is between motivation and fatigue? And are there parameters that could simulate emotional factors like that?
Well, that is so easy. I would let an audience member answer it if he wanted, but I don't know if we can pull Chris Dancy into this. So the general comment, and it's hard to hem and haw in this media, but to get to that area, we're going to have to add longer term goals. You're going to have to add attractiveness at a higher level to what you're trying to do. And I think we're going to have a way to model to let stuff from the neural level of neurotransmitters and the depletion of neurotransmitters and the physiology of circadian rhythms wash upon the cognitive mechanisms. And we have thought of this for about 6 to 10 weeks, and this is as far as we've gotten, but I think it would be, that's a very good question, and we don't really have, the fastest answer would be to go and look at the Gunzelman et al. Work, and at times use the so-called FAST equation to moderate the architecture. But I think I'd like to push it down another level into the neuro and physiological level.
Chris, I unmuted you. Yeah, go ahead.
Yeah, I was gonna say, Frank, I just got unmuted. So I guess cosign, Frank said, thinking about it, what Frank's talking about, that level, there's a couple of things there, especially if you're thinking about motivation. What you have to consider is whether you're looking at at least motivation is related to fatigue. The question is whether you're talking about the long term or the short term relations there. So short term, you might look at something like some of the other work I think that came out of Gunzelman's lab, where they looked at just time on task and how that affects motivation. But the long term stuff where you're looking at change over time or during a certain time of day, you certainly want the circadian rhythms. And then if you're looking at sleep deprivation or anything like that, you have to look at those interactions too. So once you get deeper into it and you start asking those questions, as Frank said, your life gets a lot harder, which is exciting in some ways, but can be frustrating because it's slower, right? And when you add those mechanisms in, those equations that you need, things really start to slow down in the system. And so that's one of the issues with, particularly with ACT-R-Phi, is when you're doing these things, of course, all of these systems start to slow down ACT-R, which, you know, is optimized fairly well, but it's still not as fast as you might want sometimes. And then you add these other systems and it slows it down. So you have to be willing to take that trade-off if you're going to explore that. And then again, it really depends on how much you want it. But I think it is important there. It's needed, especially as you look at these longer tasks. It's just, you have to be willing to make your life harder.
Okay, thank you. We still have a few minutes and there's a recommendation, but no more questions in the feed for now. We have,
So I have a comment back to Bill Kennedy.
Go ahead.
Yes, we could define a key that was a combination of an A and a W key. And you could, and I think the correct answer is what's going to happen is that David is going to have to add some stuff to the keyboard that ACT-R's perceptual motor module uses. But there is, I think, there has been a certain hesitancy to just dive in and modify ACT-R. And I think that's happening within my lab, and I've let it run a little bit. But there's a tension as you look at these architectures of when do you have to modify them and dare you modify it? And I think the answer is yes, we dare modify it, and we're going to have to extend that and then propose small architectural extensions in that area. But my current belief is that there's not in the current release, although I hope I'm not stepping on Dan Bothel's toes because I deeply respect and appreciate his help, that the ability to do multiple chords of keys is not something that's very well, it's at least not very well or very often used. And this task suggests that we're going to have to be the folks that go into that area.
So,
Yikes.
yeah,
Thank-
do you see the response?
Yeah, I see the response. And, you know, if you want, as my advisors told me in grad school, if you want to be told no and find out that, you know, find out what the review really should say, you publicly state, this hasn't been done before. And then people will come out of the woodwork and tell you. And so thank you very much. We will use that immediately.
Frank, this is a safe environment.
No, I'm just, there's a joke, there's a quick,
Sorry, go ahead.
there's just a quick joke. The line was, what do you do if you're lost in Africa? And the guy said, you say you're going to make a martini and use a third of it as vermouth. And the other guy says, well, how that will help? And someone will pop out of the jungle and tell you right away that's not the way to make a martini. And then you ask him for directions. So we will use that.
We have just a little bit of time left for one quick question. And there's a question about would adding a social aspect to the game, such as winning or losing or ranking, would that have some impact on motivation?
Yeah, definitely. And so at least the way I looked at it when I first was thinking of this is that Desert Bus has been used for charity events before. And so that was a thing where people would donate so much money for every point that the drivers competing in the event would complete. And so that was the main motivation for them to spend lots of time playing the game. So I think trying to model the people that participate in events like that would be very interesting, because that's a very strong motivation of giving up your personal time for a good cause. But at some point there does need to be that trade-off of, okay, now I have to go and sleep and get back to work tomorrow.
Okay,